Arduino. Today we're going to be taking a look at the servo motor, how to connect it, and today's going to be a relatively short video, being around 5 minutes, and we're just going to go over how to connect the servo motor and some code concerning the basics of it. So let's dive right in. Alright, so the first thing we want to do is take our servo motor, and I want you to notice these connections. Associate, I guess, the colors of the wires. So the yellow goes to blue, red goes to white, and the brown goes to red. So here are what the connections look like. Then as well for the other side. Alright, so I'm going to show a diagram anyways, and then we're going to get into a brief overview of code for the servo motor, and in the next video we're going to do a project with the servo motor, so look out for that. So let's look at the code now. Alright, so here's some basic code and the wiring diagram for the servo motor. Just take a quick notice that the brown wire is associated with GND. Let me just get a better view for you. The brown is associated with GND, or the ground. Red is associated with 5V, and the yellow one is associated with 9. Another reminder that this site is Walkwe, and I think it's a really good site if you're just trying to get into Arduino, or if you don't have an Arduino and just wanting to learn. So this code is relatively similar to the code we've seen in the past with the motion sensor and the wiring diagrams of the LEDs. So here we include a library. This is essential because it allows us to work with the servo motor and actually program these projects. You see again these initialization statements, making sure that the position is equal to 0, serial communication. Remember, we saw that with the motion sensor. And this is also very important because what is the significance of 9? Well, 9 is the pin that we connected the servo motor to. This is the connection for the pins. And also we want to make sure that the position of the servo starts at 0. And then we have the delay 1000, which is what we saw previously. So now reintroduction to for loops. And unlike while loops, this has a set amount of times that this will run. So this is essentially saying that it will stop only when position is greater than 90, saying that if position is less than or equal to 90, then it will continually run, and only when position is greater than 90 will the for loop stop. And so essentially what this is, these are initialization statements, this is a Boolean expression, and this is a counter. And the Boolean expression is very important because if the Boolean expression evaluates the true, then the block of code executes, and if it evaluates the false, then it exits the loop. Okay, so now let's go into what this actually does. So we're going to start at 0, and we're going to set the servo to 0. So the servo starts at position 0. We're going to get delay 100 milliseconds, and then we're going to print what the position is. And then we're going to add 1. So position is now going to be added to 1 and set to 1. So position is equal to 1 because 0 plus 1 is 1. So you write the position to 1, and then you display 1. And then you go back to the start since 1 is still less than or equal to 90. So we're going to add another 1. Position is now equal to 2. You write position is to 2. So now the position is 2, and you display 2. Then you add another 1. The servo motor has position 3, and then you write 3. Add again, 4, write 4, 5, servo motor is position 5, and then you write 5. So it's 5, 6, 7, 8, 9, 10, 11, 12, etc. And then when it's equal to 90, we're going to go through this one more time. So you're going to write the position to 90. You're going to print the position, and then after this executes, you're going to add 1. 90 plus 1 is 91. Is 91 less than or equal to 90? No, 91 is greater than 90. So that's when the loop will stop. So essentially what the servo motor is doing is it's going to go all the way to 90 and then stop. And now we're going to go to the second for loop. So I urge you to think about this by yourself. But essentially what it's doing is it's going backwards. If you start at 90 and go all the way to 0, subtracting 1, you're going to start at position 90, which is where it started here, and then display position 90, minus 1, 89, display 89, set the position to 89, and then 89, 88, 87, 86, and it's just going to keep going down the position. So essentially what is going on here is it's making it so that the position keeps going up. It keeps turning and turning and turning all the way to position 90, and then it will go from 90 all the way back to 0, and then it will keep going back and forth and back and forth. So essentially it's going to look something like this. Move this down, and you see how it's moving this way, going back up. And I think something that is also could be helpful is you can delete this. And you see how fast everything is. I just took out the delay, and now everything is so much more fast because there's no delay when it's calculating and going through the for loop. Something else you can do is you can play around with these numbers and make it so that it goes even further past. And you also see the serial monitor, and see now it's going past the 90. So just experiment with this. This is going to be a quicker video, and in the next video we're going to get into some more applications and problems.